Hi Math 1 students, Mrs. Robinson back to work practice benchmark chapter 2 and 3. I put these two together because chapter 3 builds on chapter 2. You get an introduction to functions in chapter 2 with arithmetic sequences, which then builds into the equation of a line. So let's go over the first one. Sketch a graph to represent the situation. The average temperature steadily decreases over the course of the football season. All right, if we want to describe this, if we look at a little graph, and I'm just going to make a positive and positive. If this is, hold on, let's see. If this is the time on the x-axis, usually we do time on the x-axis, and let's do the y-axis as the temperature, because we're looking at the average temperature. That says temp. All right, if the average temperature steadily decreases over the course of the football season. So if we look at the time as time goes on, if the football season starts in September, let's say September, then October, then November, over time, as the end of the football season comes, the temperature is going to start decreasing, especially in Southern California. In September, the temperature, if you wanted to label these, you could, but the temperature can be in the hundreds, in the 90s in September. And then by November, your average daily temperature is usually in the 70s, sometimes 60s. So it might look something like this. You start out hot and you work your way down cold. All right? And that is what a graph of that would look like. Okay, let's go on to number 2. All right, for the table, identify the dependent and independent variables. Then describe the relationship. Make sure you do words, equation, and graph to get full credit for this problem. So if I'm looking at independent and dependent, usually I have an x and a y. And that would be just like your equation in slope-intercept form, for example. Y equals m times x plus the constant b, okay? So if I'm looking at this, I usually will pick a value for x. I plug it in here. I do this to it, and that determines what y is. So your x value, or this column, will be independent. I'm picking that. It's independent, okay? And then your m value or your y value depends on what you pick for x, or what you pick for n in this case. So this will be dependent. This will be independent. Okay. Now let's describe the relationship using words, equation, and a graph. Well, let's look at what happens. When I plug in n, I plug in 0 and I get out 1. I plug in 1 and I get out -2. I plug in 2 and I get out -5. I plug in 3 and I get out -8. Well, how does this change? Because these are only increasing by 1, it's a constant increase here by 1, I can go ahead and look at what happens as I tick up by 1. What happens over here? So from here to here, to get from 1 to -2, I subtracted off 3. To get from -2 to -5, I subtracted off 3. To get from -5 to -8, I subtracted off 3. So let's write an equation here. We want m in terms of n. So m is going to be our m dependent, and it depends on what I pick for n. So m is going to equal n, maybe times something or plus something. Well, if m equals n, if I plug in 0, I start with my 0 term or my first term. If I plug in 0 for n, I don't get out m. My initial term, or where I start, is 1. So I get out 1. So if I plug in 0 for n, I'm going to add 1 to it, and I'm going to get out 1 for m. That works. I plug in 0, I add 1, I get out 1. Now, does it work when I plug in 1? Well, if I plug in 1 and add 1, I get out 2, but I get out -2. And the same with 2. When I plug in 2, and add 1, I get out 3, but I get out -5. So what this is the constant that I want to multiply my independent variable by. This tells me what I should multiply it by. It's a common difference. And that common difference is -3. I'm going to repeat this over and over and over again. So I'm going to multiply -3 by my n, and then I'm going to add 1. Let's see if that works. If I plug in 0, 0 times -3 is 0, and then I add 1, I get out 1. Yes. Let's plug in 1. If I plug in 1 for n, 1 times -3 is -3, and then I add 1, I get -2. Yes. Let's plug in 2. 2 times -3 is -6, plus 1, -5, and then 3. 3 times -3 is -9, plus 1 is -8. It works. So let's state that in words. In words, so I would say there's my equation. In words, I would say the value of m is -3 times the value, sorry, the writing is horrible on this. It's -3 times the value, not values, times the value of n plus 1. And that's how I'd say that in words. And then a graph, well, let's pull up a graph here. Okay, here's a little graph. If I were to plot all these points, I would plot 0, 1, so over 0, up 1. I would plot over 1, down -2. And then the other points were over 2, down 5, 1, 2, 3, 4, 5. And then over 3, 1, 2, 3, down 8. 1, 2, 3, 4, 5, 6, 7, all the way down here. Now I can go ahead and connect these points and create a line. And let's extend the line up this way and make a full line here. And that is not super accurate, but that's what the graph would look like. And lines go on forever, so you really need an arrow on either end when you draw a line. All right, and that's how you do number 2. On to number 3. Before we move on real quick, I just want to make sure you know when you guys get to slope-intercept form and you're looking at a table like this, just be aware that your common difference when you're talking about an arithmetic sequence, your common difference, if your x values always increase by 1, this common difference will always be your slope. And then the 0 term, when x is 0, that number will always be your y-intercept. So if I just looked at this and I wanted to write it in slope-intercept form, I'd be like, all right, my y-intercept, or when x is 0, my y-intercept is 1. B is your y-intercept. And my slope will be the common difference, -3x plus 1. And I can write that equation in slope-intercept form from my common difference and my 0 term. So just be aware of that connection. Okay, we're going to graph the function shown by this table. Tell whether the function is linear or nonlinear. All right, before I even create a function, I can go ahead and find my common difference and put this in slope-intercept form really quick like I just showed you. To get from -4 to 2, I'm going to add 6. To get from 2, I'm going to add 6. 8 to 14, add 6. This does increase by 1 each time, so if I want to go in slope-intercept form, y equals mx plus b. My y-intercept, which is b, this is my y-intercept, is always the 0 term. When x is 0, if this is 0, I get my y only. So your y-intercept is -4. And your common difference tells you your slope, 6 times x. So I'm going to get y equals 6x plus -4. So my y-intercept tells me I start on, if this is my y-axis and my x-axis, I start at -4, 1, 2, 3, 4, right here. There's my y-intercept, it intercepts the y. And my slope is 6. And its rise over run, I can put that as 6 over 1 since it has no denominator. I go up 6, 1, 2, 3, 4, 5, 6 over 1. You can do it again, up 6, 1, 2, 3, 4, 5, 6 over 1. Now I know this is linear because it has a common difference. And it also makes a line, which I didn't hit very well, but that's the gist of it. And make sure your line has arrows on top and bottom. Now if I were just to plot these points, you could also tell it's linear because I plot 0, -4, there it is. I plot 1 over 1 up 2, look, I hit it just doing my slope. I plot 2, 8. I go over 2, up 8. And then I plot 3, 14. Over 3, up 14, which is off the graph. But this would create a line, and I could tell this is linear. Okay, so look at your table. Just go to the graph and plot some points. If it plotted like this and made a parabola shape, then you would know it's not linear. All right, on to the next one. Okay, we want to write a rule that expresses this function. They gave me a set of ordered pairs, and they didn't put it in a nice table like before where we had it in an XY table. We can do that if you want to do your XY in a table and see if it has a common difference. So I would just go 0, 1, and the next ordered pair is 1, 5, then 2, 9, then 3, 13, and then, whoops, that wasn't very good, and then 4, 17. Okay, so I can see this increases by 1. I'm increasing by 1. And to get from here to here, is it a common difference? Well, from 1 to 5, I add 4. 5 to 9, I add 4. This is looking good. 9 to 13, I do add 4. 13 to 17, I add 4. There is a common difference. That common difference is my slope. So if I'm looking at slope-intercept form, that common difference is my slope. It's 4. Okay. And then I'm going to multiply that by x, set it equal to y. I just need my y-intercept. My y-intercept is when x is 0. That's my 0 point. Okay, so my y-intercept would be 1. So y equals 4x plus 1, and I'm done. Okay, this one wants you to make a table of values for this function, then graph the rule. Now, if I were to look at this, if I looked at slope-intercept form, y equals m times x plus b. I know the number next to the x is my slope, and then this number is my y-intercept, of course. So I can already tell you my y-intercept is -2, my slope is 5, or 5 over 1. However, this asks you to make a table of values. So I want you to do what it asks you to do so you can see another way of graphing without the slope and y-intercept. What that means is I'm going to pick some values. I'm going to start here at 0, and I start in the middle in case I want to pick some negative values. If I plug in 0 for x, 0 times 5 is 0, I get out -2. My 0 term gives me out my y-intercept. Plug in 1. 1 times 5 is 5, 5 minus 2 is 3. Plug in 2, 2 times 5 is 10, 10 minus 2 is 8. So this is how we plot things when we're not sure how to graph this. Plug in a negative number, -1. -1 times 5 is -5. -5 minus 2 would be -7. Now I'm going to go ahead and graph this by plotting those points instead of using slope-intercept. So let me just pull up a graph and let's go ahead and plot these points. I might fall off this graph, but we'll get the gist. So let's plot 0, 2. Here is 0, 0, -2. There we go. We're going to go over 1, up 3. We're going to go over 2, up 8. 1, 2, 3, 4, 5, 6, 7, all the way at the top. And then I did a negative point. Let's go -1 down 7. 1, 2, 3, 4, 5, 6, 7. So there's my points. And then I'm going to go ahead and connect them and graph this. And there's my graph. And go ahead, since it's a line and it goes on forever, make sure you put arrows at top and bottom. And that's what you should have, a table and a graph. All right, on to the next one. All right, graph the function rule. Number 6, graph the function rule. All right, and tell whether the graph is continuous or discrete. So we need to do both these things. Here's my function rule that I have to graph. And I have to tell if it's continuous or discrete. Now, to tell if it's continuous or discrete, think continuous, the line continues on. It doesn't have breaking points. Discrete would be only specific points. Okay? So remember, continuous, it goes on forever. There is no break in your graph. So it really depends on what you're discussing or working on. So let's make an XY chart. Or I was just kidding, let's not do XY. Let's do P and W for pounds or price and weight. So let's go weight for our X value, and our price would be our Y value. Okay, so here's our rule. I'm going to use this rule to make a table. So I'm not going to have negative weight in apples. They're going to weigh something. I could have no apples or no weight and no price. I could have a pound in weight, and my price would be 1 times 1.99, and it would be $1.99. 2 pounds, I go 2 times $1.99, which would be $3.98 for 2 pounds of apples. 3 pounds of apples, 3 times $1.99 would be $5.97. All right, now let's talk about this graph. Is this continuous or discrete? Well, if you go buy a bag of apples at the store, I'm not talking about whole apples. We're talking about weight. This is how we're being charged, weight. Is it possible that your bag of apples doesn't weigh a whole pound? Could it weigh 3/4 of a pound or a half a pound? Yes, it could. So that means all the little pieces in between this, you could have 2.5 pounds of apples. You could have 2 3/4 pounds of apples. And then you're going to multiply that by $1.99, and you're going to get all the prices in between here too. So this is going to be continuous. Now, if I said number of apples, only whole apples, that's all you're counting is just whole apples, not pounds, just apples, like 1 apple, 2 apples, 3 apples. Well, you're not going to sell half an apple. That would be weird or gross, because once you cut an apple open, it goes bad. So if I said whole apples, that would be discrete, because you would only have 1 apple, then 2 apples, then 3 apples. You would only have specific points. But we did weight. You could have 1.5 pounds. You could have 2.5 pounds. You could have all the things in between. So all the points are going to get covered here. We have a continuous graph. Let's graph it. All right, so here is 0, 0 on my graph. This will be my weight, and this will be my price. So weight on the X, price on the Y. So 0, if it's 0 weight, I pay nothing. At 1, I'm going to pay $1.99, so almost up here to 2, right below it. At 2, I'm going to pay almost to 4, $3.98. So 2, $3.98. I'm going to go over 2, up to 1, 2, 3, almost to 4, a little below. And then at 3, I'm going to go almost to 6, $5.97. So at 3, I'm going to go almost up here to 6, a little below. And I'm going to go from here, and I'm going to go ahead and connect the dots. I'm going to try to make that a little prettier. And I'm going to hit all the points in between because, like I said, I could have a half a pound and I could have that price. I could have 3/4 of a pound and have that price, and then a whole pound, and then a pound and a half. So I'm going to have everything in between, and that's what my graph should look like, and it should be continuous. On to the next. Okay, write a function rule that represents each sentence. All right, a function rule. So Z is, well, I'm just going to write Z is means equals 6 more than, so 6 plus more than twice Y. Well, 2 times Y. And you're done. Not too hard. Okay, the total fees, F, of a book club membership are $10 per month, M, meaning months, and F for fees, and a one-time administration fee of $4.75. So my total fees, they said my total fees will be F. Okay, this is what they are. They're $10 per month. So $10 every month. I have to do $10 times every month, and a one-time administration fee plus that one-time fee of $4.75. Look at this in slope-intercept form. The number times my variable, that would be my slope, and the constant, that would be my y-intercept. All right, on to number 9. Identify the domain and range of each relation. Use a mapping diagram to determine whether the relation is a function. Domain and range should be pretty easy, guys. Domain is your x values, range is your y values. So my domain, I'm going to say domain, D for domain. I'm just going to write the set of all my domains, my x values. So 6. Here's the x value in this point, 5. My x value here is 2. And then my x value here is 2 again. I don't need to write it again. I've already written it. So 6, 5, and 2 are the domain. That is the domain. Those are my x values. Remember, ordered pairs, if you've forgotten, ordered pairs is x comma y. That's how you write your ordered pairs. So the range is just going to be my y values. And what values are those? Well, it's the 5, the 6, the 2, and then 6 again, and I've already written there. So there's my domain, there's my range. Now use a mapping diagram. Mapping diagram looks like this, two ovals, okay? Your X and your Y. And I lost my X, I lost my pen, X and Y, okay? So I'm gonna put all my X values here, and I usually like to put them in order. Like I'm gonna write 2 first, then 5, then 6. It doesn't matter if you don't do it in order. And then I like to do these in order, 2, 5, 6. They happen to be the same numbers, they're not always, okay? And then I do my mapping based on this. 6 maps to 5, okay? And then 5 maps to 6, then 2 maps to 2, and then 2 also maps to 6. Now that is a red flag, and that right there is going to tell me I do not have a function, and this is why. Remember, if you have a little function here, when I plug in, let's say I plug in 6 into my function box, and I ask it a question or I do a rule to it, and it spits out 5. That's fine. If I plug in 5 and it does some rule and it spits out 6, that's good. I plug in 2 into my function box. The first time it spits out 2. I plug in 2 again. It's the same function, it's the same rule, nothing's changed, but this time it changed its mind and it spit out 6. I don't have a function. If I plug in 2 into this function box, every time it spits out the answer, it should spit out the same answer every time. This is a rule. The rule doesn't change. If I plug in 2 and it spits out 2, if I plug in 2 again, and this time it changed its mind and it spit out 6, that is not functional. That guy keeps changing his mind. He is not functional, okay? So here's how you tell if you have a function by mapping. If any of these X values have an arrow that goes to 2 different Y values, you are not functional. Now the case is if I have a 4 and I plug it in and I get out a 5, I can share Y values. I can get the same answer with different numbers. That's okay if you have the same Y's. Y's can share. X's, you cannot repeat an X and get out a different answer. So it's the X's that you're looking for. Do any of your X's repeat? If they do they give you the same answer? If not, you are not a function. And you can just look here. 2 repeats. 2 gives me out a 2 one time, and 2 gives me out a 6 the next time. This is not functional, and you're done. Okay, number 10, describe the pattern in the sequence, then find the next 2 terms in the sequence. Okay, this was just like the tables we were doing before, except for now we're writing them this way. This could be like term 1, term 2, term 3. Okay, and if it was an XY, it might look something like this. When I plug in 1, I get out 6.8. When I plug in 2, I get out 5.4. When I plug in, oh, that's a 3. I missed that one. Plug in 3, I get out 4. When I plug in 4, I get out 2.6. So if this increases by 1, check out and see if this has a common difference. Remember that common difference is your slope. So it's all connected together. So let's see if we have a common difference. From 6.8 to 5.4, I subtract off negative 1.4. Well, I subtract off 1.4. From 5.4 to 4, I subtract off 1.4. From 4 to 2.6, I subtract off 1.4. So, describe the pattern in the sequence, then find the next 2 terms. The pattern would be subtract 1.4 from previous term to get to the next term, okay? And then find the next 2 terms. Well, I'm just going to go 2.6 minus 1.4, and that's going to give me 1.2. So there's the next term. And then I'm going to go 1.2 minus 1.4, and that's going to give me negative 0.2. So there are my next 2 terms. Okay, on to 11. Tell whether the sequence is arithmetic. If it is, identify the common difference. So how do you tell if it's arithmetic? If it has a common difference. So let's check. From 7 to negative 5, if this is your first term, second term, third term, fourth term, just like we did on these charts back there, okay? So 7 to negative 5, you would subtract off 12. Okay, let's see if that is the same from negative 5 to negative 17. It is negative 12. from negative 17 to negative 29? Yep, negative 12. So is this arithmetic? It is if it has a common difference. It does. The common difference is negative 12. So yes, identify the common difference. The common difference, or CD, is negative 12. All right, on to the next one. Okay, you start an investment account with $3,000. All right, you start an investment account and you have $3,000 and you save $100 each month. That's awesome. So we want to write an explicit formula to represent the total amount of money you invest into your account as an arithmetic sequence. I went ahead and wrote that here. The explicit formula for an arithmetic sequence looks like this. A sub n, meaning any term, is A sub 1, meaning your first term. So this is your first term, okay? And then plus n minus 1 times the common difference. This is your difference, okay? If you were to write out your terms, if you start, think of it like this. You start with $3,000. Now, here's the trick that a lot of students get mixed up with when you're looking at arithmetic sequences. This is your first term. That's the first term you're going to have, or the first month. The $3,000 you start out with is actually your zero term. That's before you even start the first month. After the first month, you have $3,000 plus 100, or $3,100. Then the second month, you're going to have $3,200. And then the third month, $3,300. Fourth month, $3,400. And you can go all the way to the 12th month, which is what you want to know. Now, but we want to have a pattern here. And this is how arithmetic sequences work. You start with your first term, which isn't 3,000. Your first term is actually 3,100. So you start with your first term, 3,100. And then you're going to do the number of terms you want minus 1 times the common difference. For example, if I wanted my third month, which would be 3,300. Let's say I wanted my third month. I would start with 3,100, and then I would go the number of terms I want minus 1, which is 3. The third term would be, so let's go A sub 3. The third term would be, start with 3,100, and then 3 minus 1, or I'm going to go do that 2 times, and my common difference here, I'm going to add 100 each time. So my common difference is 100. So I start with 3,100 and I add 100 2 times. So that's why you always do it 1 less than the number of terms. To get from 1 to 3, you add it 2 times. To get from 1 to 4, you add it 3 times. You always do it 1 less than the number of terms you want. I accidentally erased off my stuff. Okay, so now we're going to go ahead and write explicit formula for this. So any number of terms will be the first term. This is tricky. Remember, $3,000 is when you haven't started any investing. The first month is at 3,100. So your first term is actually 3,100. Okay, plus n minus 1, and then your common difference, remember, to get from here to here, I add 100. Here to here, I add 100, is 100. Now, if you just give me this, this would be fine, but if you want to simplify it, multiply 100 through, and this would look like this, 3,100 plus 100n minus 100. And then if I simplify this, 3,100 plus 100n minus 100, 3,100 minus 100 is 3,000, so this would be 3,000 plus 100n. So my arithmetic sequence would be any term would equal 3,000 plus 100n. So here it is before it's simplified, and here it is after it's simplified. Okay, 3,000 plus 100 times n. Now I'm going to show you if I were to just write this out how I hear it. Okay, this is a little shortcut. Write it out how you hear it, like you would with slope-intercept form. Now remember, the arithmetic sequence, when you simplify it down to this, it becomes slope-intercept form. Remember, the common difference is your slope, and the zero term is your y-intercept. Look, here's my zero term, my y-intercept, and my common difference was my slope. So the arithmetic sequence is literally slope-intercept form. All right, so let's just write it how we hear it. Any number of terms. You start out with $3,000 and then you add $100 every month. Done. Look, you've written an arithmetic sequence just by how it sounds, okay? Slope, intercept. So this would look like this. Y equals mx plus b. Your slope and your y-intercept. These are switched around, but you can switch these around and put 100n plus 3,000 if you want. All right. Now we want to know after 12 months, you just plug in 12 for the number of months. So you're just going to go an equals 3,000 plus 100 times 12. And if you want to just do the math on that, okay, find the 4th, 6th, and 13th terms of the sequence described by this explicit formula. Remember, explicit formula, if I distribute the 5 to both terms and then simplify this, it puts me in slope-intercept form. All right, so let's find the 4th term, the 6th term, and the 13th term. So if n is 4, I'm going to go a sub 4. So the 4th term is just going to be 12 plus, plug in 4 for n. 4 minus 1, which is 3, times 5. Well, 3 times 5 is 15. 15 plus 12 is going to give me 27. So the 4th term is 27. Let's go the 6th term. I just go 12 plus 6 minus 1 is 5 times 5. And that, do the math, 25. Always do your multiplication first and then addition. So you're going to get 37. And then plug in your 6th term. Oh, I just did that. Plug in your 13th term, sorry. 13 is 12 plus 13 minus 1, which is 12 times 5. And then multiply this out, 60 plus 12 is going to give me 72. So that should be really easy. That's just plug and chug, guys. Just plug those numbers in. Okay, we want to find the slope of these lines. Remember, this is how I always teach slope. Remember, this slope is going down, so it's negative. So remember, going uphill, if you're driving a buggy, uphill, that's positive slope. If you're driving a buggy from left to right, down the hill, that's negative slope. If you're driving your buggy on flat ground, that's 0 slope. Now, what if I tried to drive straight up a wall? I can't drive straight up a wall unless I'm SpongeBob or some character that is an imaginary or I have superpowers. So this is undefined slope. Okay, so remember your slopes. I'm looking at this, it goes downhill, so I know I should have a negative slope. Now, a couple ways you could do this. Start at any point and count the slope. Slope is rise over run. Unless you are negative. If you're negative, then you fall first and then you run. Okay, that's how I teach negative slope. So here, instead of rising and running, running is always to the right. Unless you're negative, then you can go left. Okay, so rise and then run. Well, I don't do that. I fall first and then I run. So start at any point, and how many slots do you fall? You go down 1, 2, and I run over 1. So I fall 2, that would be negative 2, fall 2, run 1. So negative 2 over 1 or just negative 2. Now another way to do it is to look at these 2 points and use slope formula. Slope formula is y2 minus y1 over x2 minus x1. So pick a point. This point right here is the point 0, 2. This point right here is the point 1, 0. And do the formula on it. Y minus y, so 2 minus 0, over x minus x, 0 minus 1. Well, 2 minus 0 is 2. 0 minus 1 is negative 1. 2 divided by negative 1 is negative 2. So either way you want to do it. If you want to count it, remember, if it is negative, you're going to fall first. That counts for that negative and run 1. If it was positive, you would rise first and then run 1. All right, let's look at number 15. Okay, 15, just use the slope formula. y2 minus y1 over x2 minus x1. That is your slope. So I'm going to go y minus y, 3. I lost my pen. 3. No, no pen. Try again. 3 minus, and then this is a negative, so it's a double negative. Careful, those double negatives. And then x minus x. 5 minus, again, a double negative. Be careful. If you start here with your y's and you go y minus y, make sure you start here for the x's. X minus x. Okay. 3 minus negative 4. Double negative is a positive, and that becomes 7. 5 minus negative 2, that becomes positive, and that becomes 7. 7 divided by 7 is 1, so my slope should be 1. Pause. Okay, we're going to state the independent variable and the dependent variable in this situation, and then we're going to find the rate of change. Don't forget to do that part. Find the rate of change. Okay, rate of change, remember, is also slope. It's the difference in the y over the difference in the x. Okay, so let's go ahead. The independent and the dependent. So Jack's filled 10 envelopes in 1 minute and 100 envelopes in 10 minutes. So the number of envelopes they fill, or Jack's fills, will depend on how much time is given. So time would be the independent, and then the envelopes would depend on how much time they fill. So the envelopes would be the dependent. Okay? If you look at the time, if you do 1 minute, you fill 10 envelopes. So that means in 2 minutes, you would do 20 envelopes. 3 minutes, 30 envelopes, and so on. And 10 minutes, all the way down to 10 minutes, 100 envelopes. So if you want the rate of change, you just look in the change in the y's over the change in the x's. So you increase by 10 envelopes for every minute. So the rate of change would be 10 envelopes per 1 minute. So 10 envelopes per minute. All right. Okay, let's go to 17. Just with 16, remember, rate of change, this is the unit rate, 10 envelopes per minute, unit rate. Okay, let's look at 17. Y varies directly with x. Whenever I hear direct variation, I always want to write this. Y varies directly with x. That means y equals something times x. Now the reason we do this with the linear equation time, this is actually a linear equation. The y-intercept is 0. So you don't see the 0 here, but this is just the equation of a line in slope-intercept form. Your constant, or something, times x would be your slope, and then your y-intercept is 0. So be aware, direct variation is the equation of a line with the y-intercept equal to 0. So when y varies directly with x, that just means y equals something times x. They tell us y is 7.92, and then x is 2.2. So I'm going to plug in y and x and figure out what that constant is, or what the slope is. So 7.92 equals something times 2.2. Now we have to find y when x is 8. Well, let's figure out what this constant is, and then I can. So to figure out what that constant is, I'm going to divide both sides by 2.2 on both sides, and then just use a calculator and divide that out. So I'm going to come up with k equals, if I calculate this out, it's going to be 3.6. So there's my constant. Now I can come over and say, well, y equals 3.6 times x. This is how it varies directly. For every x, I multiply it by 3.6 and I get y. So I want to find y when x is 8. So I'm just going to go y equals 3.6 times 8. And when I do that, I'm going to get y equals, do that on calculator, 28.8. And you're done. Now, another way you could have done this is set up a ratio. If x is 22 and y is 2.2, you could have gone 2.2 when y is 7.92. So you could have gone x is to y as x is to y. 2.2 is to 7.92, and then you could have gone 8 over what is y. And then you would do cross multiplication. You would do y times 2.2 times y equals 8 times 7.92. 8 times 7.92 is 63.36, and then you would divide both sides by 2.2. And then if I divide both sides by 2.2, I'm going to get the same answer, y equals 28.8. So if you want to set it up like ratios, or if you just want to solve for k, either way works. All right, 18, find the slope and y-intercept of the graph of each equation. So if I look at this equation, we really to this point should know slope-intercept form. Y equals m times x plus b. So that means your y value depends on what you plug in for x, and your x is multiplied by the slope, so your m value is the slope, and your b value is the y-intercept. So you need to know that form. It's your friend, it's your graphing form. This is already in this form. The value multiplied by x is your slope, and the constant over here is your y-intercept. So slope is 6, and y-intercept is 11. Simple as that. And then you can start at your y-intercept, plot that point, and then count up 6 over 1 to graph. On to the next one. Write an equation in slope-intercept form of the line that passes through those 2 points. Now you could use point-slope form and then convert to slope-intercept form by solving for y. That's one way to do it. The book does teach you point-slope form. Y minus y1 equals your slope times x minus x1. And you would pick one of these points and use it for x1, y1, and then you would find your slope using these points and then solve for y. That's one way to do it. I prefer just to use slope-intercept form. Why mess with another form? I don't even need point-slope form here. So I'm just going to go, all right, I want it in slope-intercept form. Y equals something times x plus that constant, that y-intercept. M is my slope. So I'm going to come over here and go, okay, I can know the slope. The slope form is y2 minus y1 over x2 minus x1. That's how I figure out my slope. So I'm going to go y2 minus y1. So I'm going to go 7 minus negative 1, double negative there. Negative 8 minus negative 4. Negative 8 minus double negative again, negative 4. I started here and went here, so I start here for the x's and go here. Now I'm going to go ahead and do the math on that. Add that. 7 plus 1 is 8. Negative 8 minus negative 4, that becomes plus. So I have negative 8 plus 4. These are opposites. I subtract and then attach the sign of the bigger number. Negative 8 over 4, which reduces to negative 2. So there is my slope. Now I've got this, y equals, my slope is negative 2, x plus b. How do I get b? Well, I have 2 points here. This is an xy, this is an xy. I can pick either one of these. These are both on the line. Just pick one. Pick this point. I'm going to plug it in for x and y and solve for b. So plug in this for x. So I'm going to go negative 2 times my x value, negative 4. Plug in negative 1 for y. So y will be negative 1 equals negative 2 times negative 4 plus b. So I plugged in my x and my y here. Careful, your x goes here and your y goes here. You got to flip those around. And then solve for b. So I'm going to go negative 1 equals negative 2 times negative 4 will be positive 8 plus b. And then solve for b by subtracting 8 to both sides. And then you're going to negative 9 equals b. Now you've solved for b, so now you have your y-intercept and you have your slope. And now you can plug it into this equation, and now you have your equation in slope-intercept form. Y equals your slope. Remember over here, your slope, we did slope formula to get that. That was negative 2 times x plus, and we came over here after we did that, we plugged in an x and y to solve for b. So plus negative 9. Or you could just write negative 2x minus 9. Either way works. All right. Okay, we're on to graphing. Remember, y equals mx plus b is our friend for graphing. This is the form we want to be in. This one is already in that form. Something times x plus a constant or minus a constant. This is not. This one is in point slope form, so I'm going to want to change it. Or if you understand point slope form, you could keep it in this, and I'll show you how to do that. If you look at this one, my slope is -2/5. This is rise over run, or because it's negative, it's going to be fall over run. Okay, so you're going to fall first. And then my y-intercept, or my b, is my y-intercept is -5. So I start on, here's my y, here's my x. I start at -5 on my y-axis, that's my y-intercept. -1, 2, 3, 4, 5. Remember, your y-intercept is when x is 0. This is 0, so you get y equals to whatever that is. So x is 0, y is -5. All right, 0, -5. And then my slope is -2/5. So I fall first. I fall 2, 1, 2, and I run to the right 5. 1, 2, 3, 4, 5. There I have it. Okay. You could change this. -2/5 is the same as 2 over -5. This is -2/5. This is a -2/5. So if you want the negative to be on the bottom, you could rise 2. And if it's negative, you run to the left 5. 1, 2, 3, 4, 5 to get another point here. So you could change it to this, rise 2, run to the left 5, and then go ahead and draw your line. Remember, your line does go on forever, so it does need to have arrows because it is going to continue on forever. So that is how you would graph that one. On to the next one. Okay, if you're a fan of slope-intercept form, I would change this to slope-intercept form, y equals to m times x plus b. If you are a fan of point slope form, I'll show you how to graph that in a minute, but let's go ahead and use slope-intercept form. I need to solve for y, and first I need to get rid of these parentheses, so distribute the -2, so this will be -2x, and then -2 times 4 is -8, and then over here I have y minus 3. Sorry, that's ugly. Equals -2, and this is an x. Sorry, the writing's really bad. All right, now I need y by itself, so I have to add 3 to this side. Add 3. And I'm scribbling over my graph, sorry. So I'm going to write this over here. I'm going to get y equals to, this eliminates, and on this side I'm going to get -2x, and then -8 plus 3 will be -5. So now I'm in slope-intercept form. And I'm going to go ahead and erase this. And now that I'm in slope-intercept form, I can see my slope is -2, and my y-intercept is -5. So I start at my y-intercept, -1, 2, 3, 4, 5. I put my point, and then I do my slope is -2. It doesn't have a denominator, so I put it over 1. So since it's negative, instead of rise over run, I fall and run. So fall 2, run 1. You can do it again. Fall 2, run 1. Or remember, that's the same as 2 over -1. I could rise 2, go back 1. I could rise 2, 1, 2, go back 1. And go ahead and draw your line. And it looks something like this. And then make sure you know it goes on forever. Lines go on forever in either direction. So that's how I would graph that one. Now, if you're a fan of point slope form, y minus y1 equals your slope times x minus x1. You can recognize this is in point slope form, where this number is your slope. So here's your slope. You can see it already. Your slope is -2. Now the problem is you need a y-intercept, or really any point. Well, if you know point slope form, you know x minus x, so the opposite of this value. Here's your x1, here's your y1. So you're going to go opposite this value, opposite this value. So you could have a point x1, y1, and you could start from there and then do a slope. So here's a point opposite this value. So instead of +4, it would be -4. And then you're going to go opposite this value. So instead of -3, it will be +3. There's a point, there's your slope. So you just go, slope is -2, point would be opposite, opposite. -4, +3. because it's minus minus, okay? So I'm going to start at my point and go negative 1, 2, 3, 4, up 1, 2, 3. There's my point. I'll start there. And then my slope is negative 2 or negative 2 over 1. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2. And you can see this line is going to end up being the same line. And let's see if I can do it, extend it all the way. So it is the same line. So you just extend in both directions. So if you want to use this form, if you're familiar with this form, just make sure you do opposite, opposite to get a point, then use a slope. Or transfer it to slope-intercept form and just know y-intercept, slope. All right, on to the next one. I am a slope-intercept form fan myself. That's what I like. Okay, this one asks you to graph, but use x and y intercepts. Instead of just you can put this into slope-intercept form by solving for y, but using x and y intercepts. Okay, remember, with the x-intercept, if this is the x-axis and the y-axis, the x-intercept, if I have an x-intercept, I touch the x-axis. So that means I go over 3, up 0. That means my y doesn't go up and down. So the x-intercept, then you're going to set y equal to 0. Y-intercept, set x equal to 0. Okay, so x and y intercepts, I want the x-intercept, I'm going to set y equal to 0. So for this one, I'm going to go, all right, 2 times x. If I set y equal to 0, 0 times negative 3 is 0. So this falls out. And I'm going to get 2 times x equals negative 6. And then I'm going to divide both sides by 2. And I'm going to come up with x equals negative 3. So my x-intercept is negative 3. If you want to put it in an ordered pair, that would mean x is negative 3, y was 0. Remember, I set y equal to 0. Okay. Now do the y-intercept. If I come over here and do the y-intercept, if I want to know where it touches the y-axis, the x value doesn't go over any. It's on the y-axis, so the x is 0. So I'm going to set x equal to 0. If this is 0, 0 times 2 is just 0. So this goes away, and I'm left with negative 3y equals negative 6. Solve for y. And you come up with y equals negative divided by negative is a positive 2. So there's my y-intercept. There's my x-intercept. This was my x-intercept. Okay. And if I want to put that in an ordered pair, you would make x 0 and your y would be 2. So my x-intercept is on the x-axis. Sorry, I'm going to erase that off. My x-intercept is on the x-axis, and it would be negative 3. 1, 2, 3. Y was 0. And my y-intercept was at 2, so up 1, 2. Only need 2 points to create a line. And now I can graph it just doing x and y intercepts. So many choices for ways you can graph. So many ways. And then you can extend this way too. And then your line goes on forever, so add your arrows. All right, there's your x and y intercept way to graph. Let's go on to 23. Write an equation of a line that passes through the point negative 5, negative 6, and is perpendicular to the graph of this equation. Okay, real quick, review perpendicular and parallel. If two lines are perpendicular, if they're perpendicular, they meet at right angles. If I'm slanty like this, they're perpendicular. This slants up, this slants down. So one would be a positive slope, one would be a negative slope. Or you can have zero slope and undefined slope. These are perpendicular. This would be positive slope, and this would be going downhill, negative slope. Okay, so remember perpendicular. If they're parallel, they have the same slope. Okay, perpendicular, one's positive, one's negative, or one's zero and one's undefined if it's this way. Okay, so I also know perpendicular slopes are, just like I said, opposites. One's positive and one's negative, and they're reciprocals. Okay, they're opposite reciprocal slopes. Right? So if you want an equation of a line, they give you a point. Now you need the slope. Here's your point. The slope is going to be perpendicular to this graph, so you've got to figure out the slope of this equation. Well, I can figure out slope if it's in slope-intercept form, y equals to mx plus b. If it's in this form, the number multiplied by the x is the slope. So put it in that form, solve for y. So I'm going to subtract x to both sides to solve for y. That eliminates the x's, and I'm going to get y, bring down the equal sign, equals 6 minus x, or I can write minus x plus 6. And I wrote it in that form because I like it to look like this. The x first and then the constant. So my number that's multiplied by x is negative what? If there's nothing written there, it's negative 1. So my slope is negative 1. Negative 1 is my slope. That's the slope of this line, but I want the perpendicular. Perpendiculars are opposite reciprocal slopes. So what's the opposite reciprocal? Well, negative 1 is same as negative 1 over 1. So if I took the reciprocal, it's just going to be 1 over 1, and then it's the opposite. So if this is negative, this will be positive. So positive 1, which is just 1. So the opposite reciprocal, if that's a negative slope, that's a positive slope. And normally, if it was a fraction, like 2/3, then it would be negative 3/2. You would flip the fraction. But here it's just 1. So you go from negative to positive. All right. If it was the number negative 2, the reciprocal would be 1/2. That would be the opposite reciprocal. So make sure you know that. Perpendiculars are opposite reciprocal slopes. So I have my slope. It is 1. This slope was negative 1. The opposite reciprocal slope is 1. So here's my slope, and here's my point. And now I can write an equation using slope-intercept form. I'm going to go, all right, 1 is my slope, and then I'm going to use this point to plug in for x and y to figure out what b is. So my y is negative 6, so I'm going to go negative 6 equals my slope, I figured out, is 1, and then my x is negative 5, so 1 times negative 5, plus I'm trying to figure out b. That's my y-intercept. So do the math. Negative 6 equals negative 5 plus b. Add 5 to both sides, and then I'm going to get negative 1 equals b. So my y-intercept is negative 1. My slope was 1. Write the equation in slope-intercept form. It would look like this. Y equals 2. And let's do it in blue so you can see. Y equals 2. My slope was 1 times x, and then my y-intercept is negative 1. And you don't have to write that 1. Remember, you could just write y equals 2x minus 1. So just make sure this slope is the opposite reciprocal of this slope, which in this case, this was the perpendicular. That's a negative 1, that's a positive 1. And if they're fractions, you have to also flip them. So be careful with those perpendiculars. That was a lot of work. So just to review, the perpendicular. First, find the slope of this line. Once you find the slope of that line, take the opposite reciprocal, so the negative, and flip the fraction. There was no fraction here, so we just took positive 1. I found my slope. Then I take my point and my slope, and I plug it into y equals mx plus b to figure out my y-intercept. And then I take my slope and my y-intercept, and I write my line. And that's how you do it. All right, on to number 24. Okay, this once again, remember, perpendiculars have opposite reciprocal slopes. So if you go up, if you're a positive slope, okay, the perpendicular line that meets at a right angle would be a negative slope. It would go down. This one goes up, this one goes down. If you're straight up and down like this, if you have zero slope, the perpendicular line would have, remember, SpongeBob can't drive up the wall, would have undefined slope. All right? So what is the slope of the line that's perpendicular to this line? Well, first of all, you have to graph this line. Where is x equal to negative 4? I'm going to borrow this graph real quick. X equals to negative 4 right here. Negative 1, negative 2, negative 3, negative 4. This isn't a y equals 2. This isn't in slope-intercept form. This is the weird one. This one's not a function. X is negative 4 here. Now, I don't care what y is. X is always negative 4. Y could be 1, x is negative 4. Y could be 2, x is negative 4. Y could be 3, x is negative 4. Here's my line right here. X equals to negative 4. So this has undefined slope. So the perpendicular, this is tricky, the perpendicular to this would be flat. So the slope would be 0. Okay. An easier problem might be if a line has a slope of -3/4, its perpendicular line would have a slope of +4/3, right? That would be an easier one. But this, you actually have to know what that line looks like. It looks like a vertical line, and you have to know vertical lines have undefined slope. Remember, SpongeBob can, but the rest of us can't drive up that wall. Okay. If you drive uphill, you have positive slope. If you drive downhill, you have negative slope. If you're flat, you have 0 slope. If you try to drive up the wall, you're undefined. So you have to be able to graph that and know, well, that's undefined, so its perpendicular must be 0 slope. So make sure you understand that. And then let's go on to 25 and graph y equals the absolute value of x minus 5 by translating y equals the absolute value of x. Now, if you did the Desmos activities, you should know y equals the absolute value of x. If I just plotted points, remember absolute value gives you only positive values. If I plug in 0 here, I get out 0. If I plug in 1 here, I get out 1. The absolute value of 2 is 2, but it's the negatives. If I plug in -1 for x and I take its absolute value, I get out a positive. -2 for x, I get out +2. So remember, you start at 0, 0, and you go 1, 1, and then 2, 2, and then here I have -1, 1, -2, 2. So my absolute value graph looks like a V. Sorry, it's so bumpy, but it's hard to draw with this. It's a V shape with my origin, or my vertex, sorry, at 0, 0. Now you should know how to shift graphs. If I shift a graph up or down, this tells me on the outside I shift down 5. So I'm going to go down 1, 2, 3, 4, 5. Here is my graph, and I have that same form. I've just shifted it down 5. So this is what my graph should look like. It should be this graph shifted down 5. So I've translated this graph down 5. So just to review with you, remember, y equals to the absolute value of x. If I add a value, some k value, some constant outside, that shifts my y value up or down. You can check it by plugging in values. Plug in 0. If I plug in 0, I'm going to get -5. That's why I'm down here. Okay. Now, if I shift left or right, that would look like this. Y equals to x minus h plus k. So if this is minus, if I shift left or right, this is an opposite value. So if I have x minus 3, that would shift my graph the opposite. This is a straightforward value. So if it's -5, I go down 5. But inside, it's a minus value. So if I shift x minus 3, I actually go right 3. 1, 2, 3. It would look like this. So this is opposite. This is straightforward. -5, that means down 5. So this graph would be right 3 and then down 5. Make sure you're aware of that. That goes down 5, and that one will go right 3. This only asks us to go down 5. I was just reviewing that. All right, guys. I hope this helps. Have a great day, and let me know if you have any questions. And good luck.